Okay, guys, Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Very good afternoon. Welcome back, all students here. So, today we have a quite short lecture, which is the final part of polymorphism. So, today we'll try to finalize the concept of polymorphism. So, as I mentioned previously, that in your project, you must implement the concept of polymorphism. You have to show me that you are already implemented this concept in your project, because this is the main aim of the project, to reflect all these concepts in your coding and implementation. All right, so today we are talking about virtual destructors. So basically, when we are talking about virtual, meaning that we have some kind of dynamic binding. We delay the link between the function name and the implementation. We delay until the runtime. It's the opposite of static binding, that during the compilation time, we have to link the method, the member function, with the implementation. So it's about the link. So using the virtual keyword in front of any method, you can use it in front of member function, in front of the destructor. Once you use this keyword, meaning that you will tell the compiler, don't link the implementation with the name of this function, just make it empty until the runtime. Based on the type, we will link based on the pointer type. So now we are talking about the destructor. Destructor is special case. In case of binding, we already talked about connecting with the standard member functions, but today we are going to talk about destructors. So by default, as we have mentioned, by default, all functions and the constructor destructor are statically bounded. It's non-virtual. This is the default one, unless you use the virtual keyword in front. So all these member functions by default will be statically binding, meaning that statically binding, the name of the function at compile time will be automatically linked to the implementation. Dynamic binding, meaning that the link will be delayed at runtime. When you use the function name based on the type, the executor will select the right functions if it's dynamic. So if class could either become a parent class, it's better to specify destructor virtual. So it's recommended that in case of implementation of inheritance, the parent class, the destructor in the parent class, it's recommended to make it virtual in order to be able access to the child. So it's better to specify virtual in order to allow dynamic binding, in order to make it dynamic at runtime. So we have here to show this idea in this example here, we have a parent class. So this is the parent class and this is the child class. All right. So now we are focusing on the destructor. So here we have the destructor in the parent class. So this is syntax, as we have mentioned, the destructor, there is no parameters. You cannot give parameters. Also, you cannot return a type for the destructor. For the constructor, you can pass parameters, but for the destructor, you cannot pass parameters. It's automatically will be called when you exit the function. If it's static object, if it's dynamic object with new, you have to use delete in order to trigger and call the destructor. So now this is the parent class. We have the destructor and we have this statement inside, destroy parent object. we have the distractor in the child class, the derived class here. So we have the statement of destroy child, meaning that this function is called. So now you see now, in terms of overriding, there is different here. I'm using different name. So it's different. It's different from the previous examples when you have the same name of the functions. If you return back, you see here in the parent class, I'm using get area function. So this is the function here. In the derived class, I must use the same name in order to make this virtual. So this is overridden. But here, the destructor, you cannot use the same name in the destructor. So in the destructor, you cannot say here, this is the parent, right? You cannot say, you have to use the same name of the derived class. So it's a bit different here. But because it's the destructor now, you can add the virtual keyword in front of the parent. We will just try to see what's the output before we highlight the problem of this kind of implementation. So now, if you look at the main function here, what we can see in the main here, we have a pointer of type parent. So this is a pointer of type parent class. Then this pointer will be assigned to what? To an object of the derived class. So you see, this is different. We have child. So we are giving the address of the child to the parent. So always when we are talking about virtual classes, meaning that how to link from the parent to the child, how you can call functions from the parent class. Those functions exist in the derived class. This is the issue, because basically from the child, you can use all functions here, public, especially public and protected members. But the opposite is not true. You cannot access this one from the parent class. So now, because we need to call these functions from the parent, so that's why we have to use the virtual keyword and the dynamic binding. So now you see here the type of this pointer is parent class, but this parent class is given an address of child. So now when you execute delete, it's equivalent to this statement is equivalent to calling what is to calling the destructor. So this is equivalent to when you call the destructor, I'm calling the destructor of parent class, because this pointer of type parent. So I have to call this destructor, sorry. So basically delete is equivalent to calling the destructor. All right. So now what's going on? Because you allocate the object here, when you use the new, what's going on in the memory? Basically, if you look at the memory, at the heap part of this memory, when you make a new object of type child, so what's going on? Because this child also is a child of parent class. So basically, this will create what? This will create an object of parent first. So you have to call the constructor if you execute this statement here. So basically you will call the constructor here first, then you will call this one. So this is the parent class. When you execute this function, you are creating an object. We have the name here in the memory. This is our memory, the heap memory. So this heap memory will contain an address. So this is the address in the heap memory. This address will be given to the pointer here. So inside, if you look inside the memory, you will see this parameter first. You have to allocate memory string. Then we have another parameter, which is the age. So basically in the memory, we allocate memory for the data, not for the functions. So we have the edge here. All right. So now when you execute delete here, basically you will delete this part only. This one must be deleted from the child class here. So this is the problem, because this pointer is type parent. So when you call delete here, you will delete only this part. You will execute this part, which will delete what? Which will delete this one. But also, I need to delete this edge. So how to access this function? You have to use the virtual keyword. Okay, guys, so this is the problem. The problem now, we are using the parent class pointer, but the parent class pointer cannot see the child functions, cannot access, basically cannot access these functions from the parent class. All right, so when you destroy the object here, what's going on? When you destroy this object, what's happening here? Although the pointer is pointing to the child, although this statement is there, created in line 37, this is line 37 here, deleting the object in line 39, deleting the object, will call the parent distractor only, because the compiler performs static binding to destroy the distractor. So how to solve it now? You have to use the virtual keyword in front of the parent class. All right, so now with virtual keyword, what we are expecting, destroy the child first. You will destroy the child. It's the opposite. You will start with the child. So you would call this distractor here first, then you will call this one. All right, so now deleting object will call the child distractor. This allows C+ to perform dynamic binding. So if we look at the example here in the coding to see what's going on, in the coding here, we discard, we show. You see here, this is the parent class, and this is the child class here. And in the main, we have a pointer of type parent, we have a child, and we are deleting. So when you execute like this, so what you will see here, when you execute this part, we have to execute here. Sorry, this the function of elephant. All right, so executing now, you see the output here. In the main, if we look at the main program here, we have an object child, so that's why we are calling the constructor first of the parent. When you create an object of the child, you have to call the constructor 2 times. The first one, you have to call the parent class, then you will call the child class. So you will see 2 statements here. Constructor of the parent will be called to allocate a memory for the parameters here. So we are allocating memory for the name, then we are allocating a memory for the edge. So this is the initial values we are giving here. So this is default constructor because we are giving values here. At the same time, it is a constructor with parameters because we are passing parameters here. So if you don't have parameters, it's the same. You can execute it because we are giving initial values here. All right, so now the constructor will be called first because we are executing this line. Then we are destroying the object. So what will be called here? Only this one. And you will destroy only this field. And this one still in the memory. This is the problem. So you see here in the output, only the parent object will be destroyed. Only the parent here. So what's the solution now? You have to use the virtual keyword in front of the parent class. So you just add here, you have to add the virtual. Virtual meaning that, sorry, we have virtual. So meaning that the binding now will be linked at runtime, at the runtime, because it is Distractor, so it will call this one first. So as I have mentioned, that the Distractor is different because it's different function here, but because of binding, you will call it here. So the compiler will know that you need to destroy the object here. If you have another child, if you have hierarchical, all these distractors automatically will be called. You just use virtual at the top. If you have another class here, which is child of the child, so no need to add virtual here. You add it only one time, right? So now when we add the virtual binding and the dynamic binding now, if you re-execute this program, you will see different output now. So function of 11, we have the new output here. You see that we are calling the child destructor. We are calling the child first, the parent first. It's the opposite of the constructor. You have to destroy the child first. Then you have to destroy the parent. It's opposite to the creation. In the creation, you have to start from the top to bottom, but in the destroying, deletion, you have to start from the child to the parent. Okay, guys, clear for you? Because we are using a pointer of type parent. If you are using a pointer of type child, if that's the case here, I'm using a pointer of type child. So you don't have this problem. No need to add virtual. Just because you are using this object, so now you can call the destructor without virtual. So if you look at the output here, after updating F11, so you see the destructor will be called. You see the destructor called because this object is of type child. So I'm deleting child. Automatically, when you call this destructor also must be called. All right, so you don't have this problem if your object of your pointer of type child. But if it type parent, you have to use the virtual. Okay, guys, clear this point? Is it clear for you why we are using dynamic binding? Is it clear for you? You have to use a pointer of type parent.
Can you run the code now?
Execute now with
Yes,
virtual.
with child. Yes. No, without virtual, just with child pointer.
All right. Okay. Now we just re-execute. Sorry. We re-execute the code now with child pointer. You see the destructor will be called in both the parent and the child. So the destructor automatically will be called. All right. But if this is parent class, the destructor will not be called. So you see now we have different output. So executing now. The destructor of the child will not be called. So you see we have different output now. The destructor wasn't called. So the object is still in the memory. Okay, guys, clear this point. You have two outputs here. This is in the case of the object is already child. There is no problem here, right? Because you cannot access from the parent. A functions exist here. In the inheritance, the opposite is true. You can access from the derived class all public members and protected members. But the opposite is not true. The parent cannot see, cannot access these attributes and functions. Okay, guys, clear this point. You must use a pointer of type parent. Okay, I hope it's clear for you. Then we move to another concept here.
Sir, I just want to ask, why do we need this virtual destructor?
Why you need this virtual? In order to, I will re-execute without virtual. So just listen to me.
Mhm.
Now what we have here? We have inheritance, right? We have a parent class. We have a child class. This is inheritance, all right? So now when you create this object here with a new uh, keyword, what you are creating, basically, you are creating an object of type child here, but this object is making inheritance with this object also. So basically, you need to allocate memory for the name and the age. So you have to call the constructor here also. So now we are building, we are allocating a memory because new here, I'm allocating memory for the name Ali must be stored in the memory. So if you only call this constructor, so this constructor will allocate memory for this one. You have to call the parent here also because the name. So we have to allocate memory for the name. So this is the constructor. So now when you destroy this object, because this pointer of type parent, so basically you are calling this destructor. So this destructor will be linked to the name. So you are only deleting the name here. But still there is this value is still in the memory, not destroyed. Only will be destroyed through this function. So this is the problem. This is the problem. I cannot delete the child. The parent cannot access the child. The child is there in the memory. So what you have to do, you have to make virtual keyword. You have to use it in order to make a link between this distractor and this distractor. They will be linked together. Once you call this one automatically will be called.
See,
Okay, you
see, see,
got my
understand.
point? Yeah,
Yep,
this is
yep.
the point. Yeah, this is the point because this type of object. If this is child, already child, there is no problem here. You will call both distractors because
So,
automatically, the child automatically will call the distractor in the parent.
so technically, only virtual can destroy virtual, and yeah, pretty much, right?
Technically, you have virtual just a link. When you use a virtual, you have to tell the compiler there is a link between this distractor and this distractor will be linked together at runtime. Virtual will make a link. You can assume it's a link between the function here, the distractor here, and distractor here. If you don't have virtual, there is no link. So the compiler only will execute this code, will not access this code. So you have to create a link.
I see. All right, thank you.
All right, welcome. Any question before I move to another concept here? Okay, guys, so that's why we need to use virtual destructor in order to make a link. So this is, we'll call both destructor. In the previous example, we are calling, in the previous example here, we are calling only the parent. But with virtual now, we are calling both because we are linking here this one. All right, guys, so this is the key idea of virtual destructor. So now we have the last concept in this polymorphism, the concept of abstract base class and pure virtual function. So abstract basic class, a pure virtual method is a method in the parent class declared as a virtual but without implementation. So I'll show you the code in order to understand this concept. When you define a class like this, we don't have attributes. I have only the name of the class and I have a public function, and this public function without implementation here. You see this syntax? This is pure virtual. We call it pure virtual method. Method get area but without implementation. It's equal 0. This is the syntax. So now if you have this kind of classes, you cannot create object in the main program here. If you have this class only, and this is your main here, so inside the main, if you say I have an object of type shape, object as, this will be error because nothing to be allocated in the memory. When you create an object, meaning that you want to allocate a memory for something, but nothing to be allocated in the memory, so it is pure virtual or abstract. We call it abstract, just the name of the class, abstract parent class. All right, so but why we need it? You need it in the inheritance in case of the implementation will come later in the child class, because get area now, if you are talking about a shape, you cannot implement this because you don't know what kind of shape now I have here. Is it circle? Is it? So that's why we call it abstract, just the abstract. Just give me the name of the function. Later, when I have a circle, I have to write the appropriate code. Okay, so if you have this case without parameters, if you have here some kind of attributes, if you have protected attributes here, protected name as a string here, so this is not pure virtual because you have something here, you need to allocate a memory for this part. So basically, we must have only functions, pure functions, functions without implementation. So that's why we call it abstract parent class. So if we return back to the slides, so a pure virtual function is a method in a parent class declared as a virtual, but without any implementation or definition. So a child class now must override. So you have to override. So this one must be virtual. Override also used with virtual. Only virtual functions will be override. So overriding meaning that you have to use the same prototype. So pure method. So pure virtual is the this is the right syntax when you declare a function as a pure virtual method. So you have to use the keyword virtual first. Then this is the prototype based on your selection. Plus, in addition, you have to use equal zero like this. So this is the right syntax. When you create a pure virtual method, you just give me the name. Later, I will implement. Get area, I need just the name of the shape of the function that will calculate the area of the shape. In the derived class, it must be overridden and implemented. Okay, clear this concept about pure virtual method. We have to use this syntax. You have to use the keyword virtual. At the end, you have to make it equal 0. All right, guys, you can also here give parameters, but you have to use at the end equal 0. All right, so you see here, I'm returning integer now. Get area is expected to take nothing, but will return integer, this virtual, and equal 0. It's equal 0. It's constant here because we are reading the area. We don't modify the attributes. Okay, guys, so these are two parts must be added to pure virtual function. At the end, you have to add equal 0. At the beginning, you have to add virtual. So an abstract class is a class which cannot have any object. We cannot create an instance from this object. As I told you, if you create an object, this will be error. It serves as the basis. It's the abstract for the child classes that may have objects. So an abstract class is created when the class contains one or more pure virtual. You can add another function here also. You can create another virtual function will return void, and this is set area. You will add integer here and you make it equal 0. So you can add more than one function. Okay, guys. So you see here, this is the most important thing. You have to add at the beginning virtual, and at the end, you have to make it equal 0. Okay, just to erase these comments here.
Doctor,
Yes.
it doesn't have an attribute.
Yeah, of course. No attributes, only functions. Cannot have.
And only in
We
public.
cannot.
And only in public. We can't put it in private.
If private, you cannot access from the child. Child can
Okay.
access only protected and public.
So it
So
can
it
be
will.
protected or public only.
Yeah. Otherwise, useless. If it's private, it's useless. Cannot access. What's the use of this one? Yeah. So this is the right syntax. Only pure public or protected methods. Pure. There is no implementation. So we call it abstract class now. Abstract parent class. But you see here, this is the main syntax here. You have to add at the beginning virtual, and at the end, you make it equal 0. Okay, now we cannot create an object from this class. So if you make this statement, this will be wrong here because no attributes here. Okay, guys, I will show you in the coding. This is the end for polymorphism. I'll just show you the coding part of this concept here. We have abstract class. You see here, this is the object here. This is the shape, sorry. This is the parent class of type shape. So I have only one pure virtual method here, get area. I have two derived class. The first one is circle, and the second one is rectangle here. Inside these derived classes for the circle, I need to use the radius here. So I have a private attribute because I make it private because I'm not expecting that I can have a derived class from circle. So that's why I'm using private here. If you are expecting there will be additional step for inheritance, it's recommended to make it protected here. So now you see here, this is virtual function here, pure virtual function. So I just offer write this one. So I'm using the same prototype. This is the prototype of this function. So I'm using the same prototype here. And then I can implement here. Right? So this is inside the circle. The same goes here. So you use only virtual one time at the parent. So at the child, there's no need to use the virtual again. Also, this one will not be used in the syntax here. All right, so this is the implementation here. So in the previous examples, if you remember, we implement this function and we make it equal 0. There is no need to make it equal 0. You just make it virtual, pure virtual function. If we return back to the shape here, this is the shape class. You see here, last time we implement this function, but it doesn't make sense the area of this shape equals 0, so it's recommended you replace this line, you just make it equal 0, empty. All right, so we have here in the main we have an object of type circle. So if you execute this line, this will be wrong here. You cannot define a shape object. All right, so here I will execute this line here. So this is error. So you need to comment this one. Then we will re-execute. Now it will be okay. So now you have the area of the circle and the area of the rectangle. So this is a function that will be called, and you are passing here. See here, because I'm using this function 2 times, there is no need to call display the area of circle, display the area of rectangle. So this is the benefit of virtual classes, virtual functions, sorry. So because you are making this virtual, so now you have a virtual object here. So this virtual object automatically will find the appropriate function. This automatically, because it's virtual here, it's automatically will be linked to this one when you pass a pointer of type circle, it will be linked to this one. If you pass a pointer of type rectangle, then it will be dynamic. This will make your coding more efficient. There is no need to do 2 times here, display area for circle, display area for rectangle. Only 1 time, and you have to make it here virtual. Okay, guys, so now here, you see here, I cannot create object, but here you can create a pointer. If this is a pointer, it's fine here. You can create a pointer because pointer is just address. There is no object in the memory. So if you execute this one, there is no error. It's fine. But if it's object here, this will be problem here because this class is abstract class. It's pure virtual class. All right, so this will be error. If it's pointer, it's still fine here, no problem. So you cannot create object from abstract class. Okay, guys, clear for you the idea of abstract class here, the abstract class and pure virtual functions. So basically, pure virtual functions used with abstract base classes. Any question before I end today's session? Do you have any question about these 2 concepts plus the distractor here?
No.
Okay, all right. This is the end for today's session. It's quite short. We still have one concept in this course, which is the exceptions. Hopefully, we will finalize within the coming next week. So I have to stop my recording here.